So let's talk about the law of sines. And the textbook proves the case of the obtuse triangle. An obtuse triangle is a triangle with an obtuse angle. Okay, so now here we will prove the case of acute angles. Okay, acute triangle. So acute triangle is the triangle with all three angles, okay, to be the acute angles. So now we will prove this law of sines in the case of the acute triangle. And let's first sketch an acute triangle. And this is the angle alpha. The length of the side opposite the angle alpha, we use the A. And then this is angle beta. Length of the side opposite the beta is the B. And then this is the angle gamma. The length of the side opposite the angle gamma is C. And the vertex of the angle alpha, we use the A. For the vertex of the angle beta, we use the B. And the vertex for the angle gamma, we use the C. So now we can draw an attitude from the vertex A to the line BC. Okay, we can draw such an attitude. And let me call this E, this point E. So now, in the triangle ABC, we have the two right triangles. So, two right triangles. And the first one is angle, okay, triangle ACD. Oh, hold on. And the first one is the triangle ACE. Now let me use the H1 for the length of this attitude AE. Okay. So this H1, and in this right triangle ACE, you know, H1 is the length of the side opposite the angle gamma, right? So by the trigonometric ratio theorem, this H1 should be equal to this hypotenuse times the sine gamma, right? So H1 is equal to this B times sine gamma, right? Now, in the right triangle ABE, we can also get this H1, which is the length of the side opposite the angle gamma. So this H1 is equal to this hypotenuse C times this sine of the beta. So now you combine these two together, you have such equation. So this just implies B times sine gamma equal to C times sine beta, right? And then you divide both sides by B, so you have the sine gamma equal to C times sine beta over B. And then you divide both sides by C, you have the sine gamma over C equal to sine beta over B. So now we establish the fourth equation in the law of sines. Now let's draw another attitude inside the triangle ABC, and this time let me use the blue color. So we draw an attitude from the point C. And let me call this, okay, D. Let me first erase this C here. So let me call this point D. And this, we use a small c for the length of this side AB. Okay. So now, in the right triangle ACD, and suppose the length of this attitude CD is the H2. Okay, let me use the H2 for the length of this attitude CD. So now in the right triangle ACD, H2 is equal to the sine of the angle opposite CD times the hypotenuse B. So you have the B times sine alpha. And in the right triangle BCD, you also have this H2 equal to this hypotenuse A times sine beta, right? This right triangle. And this H2 is the length of the side opposite the angle beta. And this A is hypotenuse. So A hypotenuse times sine beta, you got this length, okay, CD. So that is H2. So H2 is equal to A times sine beta. Now you combine these two together, you get B times sine alpha equal to A times sine beta. Now you divide both sides by B, then you get sine alpha equal to A times sine beta over B. Then you divide both sides by A, you get sine alpha over A equal to sine beta over B. And let me call this equation 1, and let me call this equation 2. So now you combine the equation 1 and equation 2, and you see sine alpha over A equal to sine beta over B, and sine beta over B equal to sine gamma over C. So we put them together, we just got the law of sines. So the law of sines is like this. You have the sine alpha over A equal to sine beta over B, and this is equal to sine gamma over C. So in a triangle, the ratio of the sine of an angle to the length of the side opposite to this angle are same. You see, this is the alpha. A is the length of the side opposite alpha, and this is B, the length of the side opposite beta, right? And C, the length of the side opposite gamma. So their ratios are same.